Okay, so you're all very welcome. This is the third in a series of 4 of Winter Skills series from Mountaineering Ireland. My name's Jane Carney. I'm the training officer there. The topic for tonight is winter navigation. So there are plenty of videos on our website around navigation. There's some shorts, about 2 to 4 minutes, and then there's some longer taught sessions that I did over the summertime as well, that are maybe about 90 minutes long, 60 to 90 minutes long, similar to tonight's length. And so you can go back and have a look at them, and they would be taught sessions. So in a meeting style where you'll see people being given tasks and then some troubleshooting, and you can practice things and try things out as well, and just start the video when you need to, so that you'll be able to practice the same tasks yourselves. It's done live time, so there is time for people to carry out whatever those tasks are. So just as a preempt for this evening, um, we have the session recorded. There is a chat there that I'm manning myself. There's a Q&A there that I'm also manning myself. And we've 370 odd people expected. So it's quite a lot, and it means it's going to be a very broad audience. It's been the start of every single talk so far. I've got people that are trainers of trainers, new to walking, in clubs, experienced hill walkers, winter walkers, and so forth. So the audience is very broad, and I will cover it in that style, not getting way too technical, but obviously I can give a lot more detail in certain areas as people need. So please take from it what you will. I don't want to intimidate or underwhelm anyone either, but that's why it's broad, because of that broad audience. And this is beyond our membership. It's not just Mountaineering Ireland members. So I'm conscious that a lot of you won't be members, and that you may be meeting us for the first time. So please be very welcome, and be aware there's another series of lectures on called Zooming Around the Mountains that are just about to start in the next week or so. So have a look on the Mountaineering Ireland website. I will send a following email as well with lots of information and links, and the video will be up on the website, as are the first 2 already. So you'll be able to kind of catch up if you've not seen the other 2. So the topics are all standalone, but there's a lot of overlap. The first was an introduction. The second was about equipment, and tonight is about navigation, and Sunday is called Winter Skills. So it will bring in a bit more about movement and other aspects for winter. It will pull together some of what we've done in the first 3 sessions, but we'll add more information to the information we've already covered. So a couple of other things just before I start properly is to be very conscious at the moment. We've got people who are new to walking, very experienced, but maybe have not been out in winter since last winter. And so you do get a bit rusty. You will be challenged in winter. It's harder work. The days are shorter. The weather's colder, so it's less forgiving, but it's beautiful, and it's a lovely situation to be in. And snow in the mountains, they look quite different to what you might have grown used to over the summer. You can travel the world to go to find winter conditions. Scotland would be our closest. We get we get winter conditions here as well. So it's something to kind of enjoy, and it's a great excuse to travel when we're allowed to. So the mountain rescue team is dealing with quite a lot of traffic at the moment, both on the roads but also in the mountains, because people are enjoying walking maybe for the first time this year, with 20% increase in walking in Ireland, north and south, which is fantastic. But obviously that brings responsibility of making sure that people are conscious of the access, that they're conscious of the land they're walking on, and to make sure that they don't leave cars blocking gates, so that it's wide enough for an emergency vehicle to get through, not just a car, but that someone might need a fire engine to go through, or a rescue team truck to get through. So just to be very conscious where car parks are quite busy or have been, that you park properly. You don't just chance your arm and park across an entrance and hope no one goes in or out of it. You're careful about that, so you don't disrupt kind of normal life for people that live there all the time by blocking gateways and so forth, and they can't go about their work or their business. So do be conscious of that. And in terms of the mountain rescue teams, they're obviously happy to come out and rescue people, and people do have accidents and get caught out, and that's what they're there for. But to be very mindful of what you're taking on, that you're comfortable to do it, that you know what you're taking on, and ask yourself the 3 questions. Have I got the right kit? Have I got the right skills to carry out what I'm doing today? Have I checked the weather forecast? So those questions will get you to reassess and think over what you're doing, and hopefully help you make some better choices. So if you're not sure, pare it back a little bit. Go lower, go shorter. If the visibility is bad, can I navigate when I can't see where I'm going? Yeah, it's a bit iffy. Well, then maybe go somewhere where there's tracks and trails that you will be able to see. Are the tracks going to be covered in snow? Oh, okay. So I can't navigate. If the track's gone, I won't know my way anymore. Maybe I'll walk in forestry where the trails are between the gaps in the trees and it's a bit more obvious. So that kind of thing of changing your route so that you're a bit safer and reducing the risk and therefore the potential for having to call for help. So just to be conscious of that. So there's a leaflet I want to mention because I know that I'll get carried away here and the session will run on ahead. There's lots of information. The Scottish Mountaineering Council have a lot of winter specific information. Glenmore Lodge, the National Centre in Scotland, they have a lot of superb winter information because it's their terrain. It's what, people go there for winter conditions, particularly as well. So it's well worth checking out their website. And there's a lot of videos on our website. There's also a lot of videos on the British Mountaineering Council website for winter navigation and winter equipment, winter travel, all of that. So there's plenty of materials out there to kind of whet the appetite for when you do have the possible chance to get outside your 5 kilometers. So this leaflet is called Be Avalanche Aware. It's the link I will put into the follow-up email. But what it does, particularly for new people, but also for experienced people, it gives you a series of things to consider and questions to consider. So it prompts you to think about the risks you're taking and how you might mitigate those risks, what you might carry to prevent certain thing to become an issue, checking the forecast and making sure that you avoid terrain where it might be avalanche risk or where the wind is very strong and you might choose not to go along that particular ridge because it's very exposed because that's where the wind is going to be coming from, or where the snow is going to be building up, blown and cornicing, for example. So that leaflet's a very useful piece of information to help in that decision making process, which is difficult when you're new and never easy when you're experienced. It's always a challenge. So definitely to consider those. So just in this session this evening, I suppose I want to try to differentiate from your summer navigation into winter navigation. And I will still cover a lot of the summer skills because obviously you're going to use those, but to try to show where there's a difference in how you might change the way you navigate or what technique you might choose to use when it's in winter compared to summer conditions. So in terms of the summer and the winter, some of the key differences are it's going to be colder, the day is shorter, and it's going to be windier. You're probably going to be trying to navigate with gloves on because it's too cold to take them off to take a bearing. And the visibility is more likely to be poor. Because either the short days you may get caught out at night or because of bad weather and cloud and snow on the ground added to that can create conditions as a whiteout. So you've no reference point. You can't distinguish between the ground and the sky. And equally, the terrain you may have become very familiar with will be covered in a blanket of snow and it will make it look quite different. It softens everything and it conceals things, rivers and boulders, boulder fields, scree slopes. It can hide lakes, streams. So what you're used to being able to use, the nice line feature of a stream may not be so visible anymore, but you might still be able to see an impression, an indent where that stream is underneath, but it's covered in snow. And the same with the edge of lakes and so forth. So it may start to make you think, I'm going to look for different features to navigate by because that big lake is not visible anymore, but the big flat area that the lake is in is apparent in the snow. So it will start to affect the route you take. You can't just go anywhere. You can't just always go the way you've been before. The track you always used before may not be visible anymore. And you might have to navigate, in essence, cross country because you've got no line feature to go on. So it's important that all of those skills that you've been building up over the summertime are practiced and kept practiced. And then when you come into wintertime, it's not adding a whole pile of navigation on top of a weak base. It's adding a whole pile of navigation on top of a fairly well-established base. So practicing good weather when you can see your errors and you can see where you should be when you walked on a bearing, and do it regularly. So it's not just pulled out when you're in trouble. So you develop good habits and good practice. I mentioned briefly, and I've hardly talked about the weather all through this because it's not really a weather course as such, but having a forecast in summer and having a forecast in winter you can have very similar conditions year round in Ireland. And it's really important any day to have a weather forecast and to know what's going on. But if you choose not to, in summer it might be more forgiving, it'd be milder, and the visibility may be better. You're not going to have snow underfoot in general, and the day length is longer, so you've got more leeway to make error and correct it. Where in winter, leaving a little bit late, the day is shorter, not checking the forecast, not knowing what's going to happen, you may choose to walk up into a headwind when you could have it at your back, for example. You may choose to walk on slopes where the snow has been dumped and avoid the nice, easier ground where it's been scoured, and end up in riskier terrain. So it's important that you do check the forecast, the wind direction, the wind speed, and what time these things are expected. So you know that there's a big band of snow or rain coming in the morning, and you arrive at lunchtime and nothing's happened yet. So maybe it's running a bit late. So you may think it's going to come in the afternoon. So it's important to do that and to start looking at that forecast a good bit before. So you've got a pattern building up over the week and you get an idea and a feel for the weather forecast and the wind direction and so forth, and where the snow might be lying now. If you're in the likes of Scotland, you can get an avalanche forecast. In Ireland, you can get a mountain forecast as well as in Scotland. And that will give you information in a picture, a rose, a dial with spokes, and it will tell you what's level of risk and also what height the snow line might be and the visibility might be. So it gives you some very useful information when you're planning your route as to how high I'm going to go. Do I need to bring my crampons, for example, and an axe? Or as there no snow on the ground, there's no avalanche risk. There's, you don't need to carry that bit of extra heavy kit. So it's really important. I can't stress it enough, but we don't have time to go through a full winter weather lecture, maybe another one on the list to do. So all of that combines to affect your route choice, where in summer you can pretty much go where you like if the terrain will permit. If you're a climber, you could go up a cliff. If you're, you're a walker, you can go up the spurs and around things. So, but in winter, it's not that simple. If the slope is loaded and at risk of avalanche, then you can't necessarily just escape down that nice easy slope. You may have to go around a ridge or go off on a different aspect, different facing slope, so that you're on safer terrain. So you do have to think a good bit about that when you're planning your routes, that ideally the night before. So with winter, I would always plan the night before with the forecast, when you're warm and dry, with the map out on the table and a few friends around to discuss things and share ideas and thoughts on what you think is safe and good to do. That I will send, I just see a question in there about a weather forecast. I'll send a link with a mountain forecast. I think it's linked on our website as well. And there's Met Éireann, of course, but also there's a mountain weather forecast. But I'll send the link in the follow-up email later. So you'll be thinking of things as well about exposure. It's obviously a lot colder. The wind is stronger. The temperatures are lower. And if you're up high, it might be raining at sea level and snowing up at the top, which can sometimes be a nicer prospect. But if you're on tops of mountains, if you imagine the wind on the side of a mountain coming in and getting trapped into a smaller and smaller space, and it's speeding up onto the tops and hitting you. So, having a mountain forecast can be very useful, where they'll tell you what the temperature is up at that height, not sea level temperatures, which is what your normal forecast is going to tell you. You need to escalate the temperature or decrease it depending on where you are in altitude. So if it's 0 degrees down at the valley bottom, it could be minus a degree to half a degree every 100 meters that you go up. So it's going to be a lot colder. So if it seems 8 down at the bottom and you're going up an 800-meter peak, you could be down to 4 to 0 degrees. And then if you add on the wind and the wind chill factor, you could be tipping into minus figures again. So I think it's really important that you become familiar and get practiced in looking and interpreting forecasts, and then building up your experience and then applying that then to your route choice and where you're going to go. Okay. some small tips and tricks with your maps. So if you're in winter, I'd always carry a spare map because there's a fairly high chance of the wind catching it and blowing it away. You could put it into a map case or laminate it. The benefit, I suppose, of having a map case is that you can tie it onto something, so it makes it more difficult to be blown out of your hands and lost. If you laminate the map, it's smaller, and you could also cut your map down, laminate the section, make a copy, and as your spare, you're allowed to do that for yourself. And then it's small enough to fold into your chest pocket. You're not going to take it out of your rucksack very often, but you will pull it out of your pocket if it's handy. So I definitely get a smaller section of map, laminate it and stick it into your chest pocket and keep a spare in the pack, and make sure other people in the group have spares so that you, if it does blow away, you've got spares one way or another. The same with your compass. I always tie my compass on either to my rucksack strap, because I'll always have that, or onto my rain jacket. The difficulty if you tie it onto the strap of your jacket is you may take the jacket off and then you have to start undoing it and putting it onto a different jacket. So all the compasses have a piece of string on them. So when you're, rather than tie a knot, push it through whatever you're going to push it through and overlap it. Like so. So there's no knots to untie, because you'd never get it off if you did need to remove it from someplace and put it somewhere else. And the length, it's probably about from my elbow to the tip of my finger long, just so that you've got enough room to move the compass out from you, to move it down onto the map to take the bearing, but not long enough to garrote yourself. And don't put them around your neck, and they'll get twisted and tightened. So you can, I often clip that to my, like I say, my rucksack strap, and then I stick it into my pocket out of the way. The other thing that you can do that's really handy with maps, if your eyesight's a little bit weak, or just if you want to see more clearly, you can blow the map up on a copier. Just make sure that your scale is exactly double. So if you're blowing up a 1 to 50,000 map, and you can blow it up to double the size to 1 to 25,000, and then laminate that, it just makes it a lot easier to see. It's a little like on your phone if you use an app with a map on it, that you can pinch it out and make it bigger, so you can see the detail more clearly. You can you've got a longer line to do your bearings from A to B, so it can make life a little bit easier if you're trying to navigate to find details and look at the detail on the map. Okay, so in terms of the compass as well, there's quite a lot of compasses on the market. Someone was asking what brand. I've used the same brand since I started navigating, because at the time I was told that's best, that's the one everybody uses, and I've never changed. But there are good other brands out there. Something like, I don't really like branding, but anyway, something with a large base plate, and so you can see it a bit better. So a large base plate, so there's plenty of edge to measure things with. A magnifying glass just in here, so if you do want to scrutinize the detail, you can. Underneath this compass, there's little rubber bungs, so it helps to grip on the map when you're trying to hold it down to turn the bezel here to take a bearing, because otherwise it just slides across the paper. And on this map, it's got the scales in Aroma for the different scale maps. So if you're flicking from a 1 to 50 to a 1 to 25, you can do that. But always on a compass, you will have a ruler, so that can measure any scale map. And I'll talk a bit more about distance measurement and how that works as well. With the other bits and general things around compasses and around carrying them, please make sure you don't have anything metal in your pocket. So your mobile phone, bunch of keys, those kind of things, and your if you've got an ice axe in your hand and you're taking a bearing, the metal will draw the needle towards it rather than to the magnetism that it's trying to follow. So just keep metal away from the phones and any devices, away from the compass. It's a bigger issue these days because most people have phones very close to them all the time. So just be very conscious of where that is. Phones don't like cold, batteries don't like cold, so you're trying to keep that warm so that it doesn't discharge. So often people put them next to the, in the chest pocket or in the hip pocket or something. So just consider where you're going to store that. Let's check. Okay, one question in the chat. Yeah, like I said about the weather forecast in the mountain weather forecast, I will send you the link to it. So you'll be able to find that then. I don't remember the link name off the top of my head. So other devices that people can carry, obviously a GPS and a smartphone, a smartwatch, an altimeter can all give you an indication of the height you're at, the location you're at. Your smartphone, you can download an app called OS to Grid Converter, and there's others which will give you a grid reference and a pinpoint where you are. So as long as you know how to do a grid reference, you can find yourself then, locate yourself on the map. I wouldn't 100% rely on them, and a GPS is not going to compromise your battery power of your phone. But if you're in difficulty and you have a device with you, there's no reason why you can't look and see, and get some assistance. Gather your information, as I'm going to talk about, and you can use that to back up what your when you look around yourself says and see, can you find yourself that way? So just bear with me a second. There's a few bits and pieces coming into the chat here. Okay. There's a thing called, you can use a marker pen on laminated maps as well, and just a bit of metal will wipe it off if you want to make notes. You can get China graph pencils that you can write onto maps with again, that will come off afterwards, if it's wet conditions. I've never heard that one about sandpapering your laminate, and then you can write with a pencil. So I'd have to try that one out. I'm interested in that one. I've never heard that one before. The magnet in the phone speaking and make the compass short. Yeah, so it is like, when we talk about bearings in a bit, there's something that you do in that process that will help protect against a bearing being drawn by something else and you're not noticing it. So I will come to that. Yeah, anything really that's a lump of metal will cause the compass to. And Kevin, what about a basic navigation course? So I'm not sure if you're asking if we have them, or suggesting that people should be navigating with a map and compass, which I would totally agree with, as well as any other devices that they may need. But yeah, there's a mountain skills course that teaches all of this about looking after yourself in the mountains, navigation wise. It's not a winter specific course, but yeah, that's where I would start. If you have no navigation skills, then I would definitely recommend a mountain skills course. Thank you, mountainforecast.com. So that's a very useful website there. Okay, so I'm going to press on. Okay, so we need to get on to a bit of navigation. We can look at a few different things. In winter, there's a few tips and tricks that I'll pull in towards the end about how I would differ my navigation techniques because it's winter. But some of the basic, the fundamentals, they're not basic, they're very much a fundamental. You need to be good at them. Would be measuring a distance on the map so you know how far to expect something to be. And for that, you can use your compass. It's a ruler. So if you do have a map and compass with you, then if you place your compass onto the grid of your map and work out how many millimeters are in each of those kilometre boxes. So just whatever map you've got to hand. I just happen to have pulled out Scottish maps. I think to try and get into the winter mindset. So if you look on the top, the millimeters, and then I'm just going to put the 0 on one of the lines, and I'll read across then and see 40 millimeters. So this is a 1 to 25,000 map. And then on a 1 to 50,000, it's half in size. So each of those boxes there, which is a kilometre, will only take up 10 millimeters. You can see that there, that's a bit clearer. Okay, so regardless of whether you know about scale, whether you know what scale map you're actually on, if you measure with the millimeter scale, you can use any scale map. So each box is a kilometre, and the 1 to 50 takes up 20 millimeters, the 1 to 25 takes up 40 millimeters. So if it's a 1 to 50, each millimeter is 50 meters on the ground. And if it's a 1 to 25, each millimeter is 25 meters on the ground. And if it's a 1 to 30, you can fill in the gaps, and a 1 to 75 and a 1 to 90, or whatever, the millimeter is going to be whatever that is. So it's a very quick translation between different scale maps and you always will have a millimeter scale on any compass. So it's a universal measurer, the ruler, and a translation that is easy enough to remember. 2 millimeters and 1 to 50, that means it's 100 meters in distance. So because this is a webinar and I can't see anybody, if you want to just double check that you're happy, you can measure the millimeters on a scale, pick a couple of features and measure from A to B. That's what you're looking at. There is a video on our website that goes through it piecemeal with photographs and diagrams. So you can come back to that and practice it if it's not clear to you. But one of the reasons why you're measuring distance is to allow you know how far to expect the next feature to be. So, you know, if you're a rough idea, 100 meters is roughly a soccer pitch or a football pitch-ish, or a 25-meter swimming pool. Some people might be familiar with a 50-meter pool, but there's not that many. So just to get your eye in as to what that distance actually means. And equally then on the land, what does that look like? So again, most of you know what a football pitch length looks like. So you can visualize roughly 100 meters. So when you do measure a distance on the map and it's 200 meters, you think, right, that's 2 football pitches. Okay, that shouldn't take me very long. And if you're walking for, you know, a good long while, then it's not 200 meters anymore. It will ring an alarm bell. So the other way to plot your progress, once you know the distance that you want to travel, you can use your steps. You can count your steps, and it's called pacing. So you can use your footprints, your footsteps, to know how many steps you take in 100 meters, and then you can pace out. If you've got like a 200 meters, you can do that twice. So a task to do, and again, there's a smaller video on this on the website as well, but a task to do is to find 2 places on your map and measure them. And find something that's 100 meters apart, and then start and walk and count each time. Say your right foot touches the ground, and then when you get to the point that you've said, turn around and walk back and see if you get the same number. Maybe do it a third time and get an average. So you'll end up then with a pacing for 100 meters that's every double pace, because you're just picking one leg, of around 60 to 80-ish paces, depending on how long your strides are. And you might do that in the first instance on fairly flat ground, on a track or something. And then you might try it on grassy terrain or on slightly uphill terrain or very steep uphill terrain, and the same in descent. So after a while of practice, you will end up with a number that's your normal kind of basic pacing on flat, easy ground, slightly more uphill ground, a very steep up, very steep down, and a very shallow down. That might be good for summer, but then when you come to winter, you've got snow on the ground, so you might redo your pacing. You can't walk as fast in snow. You can't stride out as much in snow if it's really soft and you're sinking into it. But if it's very crisp and hard, you might find you can do longer strides. So you really need to reassess it and do that test. Go forward 100 to a feature that you know is 100 meters away, come back, go forward and get an average, so that then you know what your pacing is in that particular terrain. And it can be very accurate once you've practiced it, and you can make a note of it on a card, a wee table. And then on the back of that, you can take your distance and work out how long it's going to take you to travel that distance. You can use timing. So your timing, there's a formula, again, another short video on the website about how to work out timing. But from our old physics classes, speed is distance over time. So you need your distance, which is why we measure it. And then you need to know what speed you're traveling at in order to work out how long it's going to take you. So somebody's done that for us, and Naismith. And there's a table on a presentation on the website as well with how long it might take a group. And they reckon 5 kilometers an hour in normal conditions with a group is the average kind of speed of a group. In winter, I would drop that down to about 3 kilometers an hour realistically. It's heavier kit, tougher ground to walk through. So 3 kilometers an hour. So it might take you 20 minutes to a kilometer. And then you can break that down. So if you're going to do half a kilometer, it'll take you 10 minutes, or a quarter of a kilometer, it'll take you 5 minutes. So when you go to measure your distance, you can then equate that. What speed am I going at? And you can equate that to a time it's going to take you. The other aspect of that equation is the height gain that you're going to bring in. So if you're traveling on flat ground, it's easier, and it's actually shorter because it's as the crow flies, which is what you're measuring on a map is the crow flies. But obviously when you're on the ground, you're not walking on flat ground if you're going up a hill. So it's the diagonal line between those 2 points is slightly longer than the flat line between those 2 points. So your pacing number will increase, but also your time will increase. So again, the quick way around that is that any time you cross a contour line, which are every 10 meters in height on most maps, every time you cross a contour line, you can add a minute to your time when you're going up. If there's 10 contours to climb up, you'd add 10 minutes to your overall time to accommodate that extra distance and the shorter stride you're going to take and the slower, more effort you're going to put in to climb a hill than to walk on the flat. So again, I don't think there's really time to do too many tasks and sessions, but if you want to have a look at your map, pick a top and pick a feature around a box away and measure the distance, which is going to be around a kilometer, and then look at how many contours you're going to be going up to get to the top and do a rough guesstimate of the time that that's going to take. So I'll just recap. At 3 kilometers an hour, 1 kilometer is going to take you 20 minutes, half is going to take you 10, quarter is going to take you 5. So measure your distance and then count your contours uphill, and it's 1 minute for every contour. So I'm working on about a kilometer, so that's going to be 10 minutes. And I'm going to imagine there are 10 contours. So that's 10 minutes. It should take me 20 minutes. Sorry, 1 kilometer should be 20 minutes, and then 10 for the contour. So it should take me 30 minutes to get to the top. 20 for the distance and 10 for the height gain. So that's how we use the timing then to work it out. You could pace as well, and that will tell you when you've traveled a kilometer. It's a bit miserable pacing for long distances. So tend to use them for the short bits. You go to the big feature and then use the pacing to get into the little bits at the end. But you can do both. If you're in bad conditions, it can be very reassuring to have the two going at the same time. One person maybe pace and the other one time, or you can both do both if you wish. Just see. Thank you for answering the OS to grid. Naismith, yeah, I think whether he did directly factor trigonometry into his formula, or whether he just timed people and knew that people take longer on a hill. Either way, it is actually a longer distance. If you can see from my thumb, this is your kilometer distance, and you then are putting on a hill, you're still measuring that distance on the map of a kilometer, but the actual distance on the ground if you're climbing is longer than the kilometer. So whether you do it mathematically or not, the pacing, you'll add some paces, the timing, you'll add some time for the contours. It's a bit of a difference to being in the classroom and doing maths back in school days and trig and getting a bit glazed, to doing practical maths on the hill based on what you're observing. And it does come back to maths at the end of the day, but it means that it's tangible, that you can remember to do that on the hill. So that's kind of a nutshell of timing and pacing, but they're both used to plot your progress on a journey. And the timing can be very useful as well, especially when you're planning the whole day. So you may choose to do, 6-kilometer walk with 600 meters of climbing. So you can then say that's going to take me X number of hours. So I've got a lunch to fit in, or a few stops to fit in. So that's going to take me another hour. And the daylight hours are from here and here. So actually that's too much. I can't do that in 6 hours. I need to shorten my route or reduce the height so that I can get it finished in daylight. So that is another really useful, I find that one of the most useful things to use timing for, is to plan my day out to make sure that I've got time to get around with a bit of wriggle room for someone being a bit slower, or having to stop to put on a plaster, or go to the loo, or whatever it might be that slows your group down that bit. And so you don't get caught out in nighttime. So yeah, there's a couple of questions here. Please clarify that 1 minute only applies to 10-meter contours. So yeah, so what they're saying is for every 10 meters you have to climb, add a minute. You can play around with that. If you're a faster walker, you might add 30 seconds, but yes, that's what Naismith is saying. So on some maps, most maps are 10-meter contour intervals between each contour line, but some maps use 20 meters or 15 meters. So then it would be 2 minutes per contour for those maps, or 1.5 for the 15. So it's per 10 meters. And it just happens to be that contour lines are 10 meters apart for the most part on the Ordnance Survey maps, and lots of the others. So yes, that's what I'm getting at. Okay, I'll just check the other couple of questions. Yeah, so is the 1 minute contour timing the same in winter or summer? So yeah, this is where you get to play and to be sensible about playing with it. Put that down a second. So if your walking is slowed down, you would probably change the speed you're operating at, rather than playing around with how much time you give for a contour line. So by that, I mean, I said that we probably walk about 5 kilometers an hour in normal kind of conditions, not winter. But when it's moving into winter conditions, I would tend to work off more of a 3-kilometer, because we're moving slower. So that's where I would make that adjustment, and how I would make that adjustment between the winter and the summer conditions. But the other thing that you can do, like with the pacing, you can find two features that are 500 meters apart or a kilometer apart, and time yourself. So you get a real measure of how long you're taking to travel that kilometer. So it's, so if it takes you 30 minutes to travel a kilometer, and it's flat, then you're moving at 2 kilometers an hour. And that might be because you're wading up to your hips in soft snow, which does happen, and it's very tiring. And so your speed could go right down, and that's, the height gain isn't an impact at all there. It's just the fact that you're wading. So you would adjust with the time it takes to cover the ground, as more so than how long you're going to allocate for each kilometer, for each contour. The other thing also is that you wouldn't generally add time in descent, because you're more likely to be moving as well as fast as you would on the flat, unless you're moving down something that you have to be very careful on, and that you have to zigzag lots, so you're walking a longer distance and so on. But again, you can time yourself and see, well, actually, how fast am I? How long is it taking me to cover this ground? And your body is a good indicator of when you're slowed down, if your pace is shortened because the snow is so deep you can't do a normal length stride. So in summer, you might take 70 paces for 100 meters, but in winter you might take 90 or 100 or 120, because you're wading, or you're plunging into your footsteps are going so deep, or it's very steep and you have to take shorter steps. So, be prepared to play around it, but do be prepared to measure it and pick a couple of features at the beginning of the day and see how long it takes you, see what your stride length's doing, see what the snow is, how the snow is affecting your steps, and then make note of that and accommodate it by adjusting your pacing and your timing speed. That makes sense. So, yeah, so just someone has put in there, you can get a wee timing card. We give them out as part of the Mountain Skills pack, but you can download them. You can buy a clear laminated one with 2 kilometers an hour, 3 kilometers an hour, 4 kilometers in a table, and it will tell you 100 meters will take you 1 minute, and 200, and so forth, for whatever speed you're traveling at. So you can get that, and then on the back of it, you can write your pacing numbers down. So you can laminate that and then attach it onto the string of your compass, so you've always got it. And that means you don't have to do too much maths when you're on the hill, and you can use that to make very quick distance measurements, timing calculations, and be gone, because you don't hang around in winter. You just get cold if you do. Okay. Yeah, so somebody prints out the Naismith rule, and some companies have cards the size. So yeah, you can get a hold of those, or you can make your own and laminate it. I think they're about 50 pence, depending on where you get them from. Okay, and there's just a couple more questions there that I'll just have a quick look. Yeah, so someone else again, Rachie, was saying about the extra gear that you're carrying. So again, your speed is going to be affected carrying a heavy pack, walking in heavier snow, maybe having to wear rain gear all the time and bigger boots. So that's how you would adjust your timing by the speed that you're going to be traveling at, more so than the contours. Yeah, I can have a look at norths when we get onto bearings, okay? In terms of GPSs, there's plenty of them on the market. There's some very popular ones. If you go into an outdoor shop or onto their online website, you'll see a particular brand comes up all the time. I'm very loath to be a brand marketer, but you will see which ones are there all the time. They're like, you can use an old smartphone. You can use those as a GPS. It'll tell you where you are. You can download maps onto them, View Ranger, that kind of thing, where you can download the sheet that you're using and plot where you're going and do everything you can do on a GPS. But they do drain the battery, so definitely, most people have old phones lying around that they could bring, and they could bring a spare charger, a battery pack to keep them going. But there's plenty of GPSs on the market, and like I say, there's one particular company that is very popular. It's anyone that sells them will sell this particular brand as well. But just to make sure that they still have compatibility with the maps, and that you can still get access to the maps that work on those particular devices. But they're much smaller than, I remember getting one a long time ago. I was bought one, and it was like the old mobile phones that are about this long, with a big aerial sticking out the top, and they were bricks, huge, but they're very slick, small devices now. So, but yeah, there's lots on the market. Yeah, so I will be looking at all the different types of bearings. Okay, Helen, that's fine. It'll be videoed, so you get to finish the end if you're keen to. Thanks for attending. Okay, so I'll move into bearings now. It's something that people are very keen to find out about. There is a video on the website. It's about how to take a bearing. So just in answer, Josh was asking there, what's the difference between true north, grid north, magnetic north? So grid north, as it sounds, is from the grid of the map. So a map is drawn on a square grid, and magnetic north is a force. So the magnetism is causing the needle to be drawn towards it, and it's a natural reference. The grid north and that squareness of it. The Earth is not square. This is a simplification. I don't mean to patronize you, but to just give you a handle of what I'm talking about. So where the map is square, the Earth is curved. So there's a difference. So the grid north is straight, if you like, straight up, and the magnetic north is going off in a curve. So the two of them are the ones you use as navigators, grid and magnetic. You measure your grid north off the map. You're measuring an angle from north around to wherever your feature is. And then the needle, the compass needle, responds to where north is on the land, the magnetic north. So you then, once you've measured your grid north on the map, your angle, you can then turn the compass, and I mean turn it like this, around until the magnetic needle, this isn't floating because it's vertical, this magnetic needle sits inside where the north is showing on your compass. So you're using the natural magnetism, and then you're using the information, the angle you've measured off your map, and then true north, north pole. So that's not much use to us as navigators, but that's the difference between the three. There is also a presentation on three norths, like a PowerPoint type presentation as well, where you can spend a bit more time. So the reason why grid and magnetic is important as navigators is like I say, you're measuring one angle off the map and trying then to translate that onto where do I walk on the land, and you're using the magnetic north to direct you. So the correction that you need to make from a grid to a magnetic is written on the map, and it tells you how to work it out. The trickiness, I suppose, about working out that correction is that magnetic north is consistently inconsistent. So it changes yearly by a different amount. So there's nothing fixed. So when you're measuring off the map, say you measure 90 degrees, you're traveling somewhere that your north is here, and probably that direction actually the way you're looking at it. So this is north, the top of the map, and you want to go straight out 90 degrees to the east. That angle there is going to be 90 degrees. That's on the map. But on the land, that magnetic north is a slightly different degree. It'll be 90 plus a few degrees. So on your map, in the, I hope I've got an Irish map here now, but I think I've got all Scottish maps. Yeah, so here, you can see it. Sorry, I was just a bit low. Right, sorry there. So there you can see the grid north, magnetic north off to the side, and the North Pole, true north. And then to the side of that, there's a box of text. See underneath here, just where my finger is, there's a box of text. It'll be in the same place on your map that you have. And what it'll do is tell you the difference between the grid north and the magnetic north and the variation. So how to work out that correction. There's a much clearer video on the website with me describing this, but it will tell you, you need to know the year, you need to know how much it changes every year and what the starting point was. So if this map is 10 years old, and at that time the variation was that you should take off or add 5 degrees, then 10 years ago, 2010, the variation might have been 5 degrees, let's say. And then it says every year it decreases by 10 minutes. So in 6 years, it'll have decreased by a whole degree, 10 minutes in a degree. And in 10 years, it'll have decreased by a degree and 40 minutes. So that 5 will have gone down to 4 and then to 340, which would round up again to 4. So that's what you would have to adjust your grid bearing to. If people are glazing over who've never taken a bearing before, it's a bit of a snapshot on how to do it when you don't have the skill to maybe take the bearing in the first place. Don't worry about it too much, but do have a look at that video where it just focuses in on taking a bearing. But that's what you're adjusting for. The grid is straight, if you like, and the earth is curved. So you're making that adjustment so that when you do go to walk on it, it means something on the land. So that's a very nutshell of bearings. And the other aspect of bearings is walking on them. So once you've measured your bearing, which when I was saying to you is your angle from north. So you've put your compass, the arrow here on from A to B where you want to travel, and you've turned your dial to line up with the grid lines on the map, and then read your bearing off the top center here. So this one is saying 60 degrees. I then take that grid bearing, and having worked out what that variation is, I say, right, it's 4 degrees. So my grid moving on to land is I add on my 4 degrees, each blip is 2. So now it's 64 degrees. So then when I want to walk on it, I have to turn myself with the compass in front of me around until I can see the red needle sitting inside this one here. Just not flat so it doesn't settle. So I can see the needle sitting inside that red arrow behind it. It should be exactly over the top of it. A compass works on the flat, that's why it won't swing when I hold it up to the screen. And once that's lined up, this arrow will tell me which direction to travel. And you keep it held in front of your center, turn your shoulders and line it up, and then look ahead of you and pick out ideally 2 or 3 things on your way to join the dots to, and then put down the compass out of the way and walk to them, stop and then check it again. In winter, there can be difficulty with visibility. You may have no features because it's all white. Everything may be covered. There's no vegetation, no tree, boulders, or anything that you can see to use to say, oh yeah, that's where my bearing is going to. So you may choose to send a person ahead of you so that you've got something to sight and tell them left a bit, right a bit, and then get them on in the right line and start leapfrogging one another so that you can stay exactly on your bearing. If the terrain you're walking on, if you're worried that there's steep ground, you take a bearing a good bit away from any edges. So your route choice is going to be affected that way so that you don't risk falling off the side. And in some cases, you may choose to use a rope, even if you're walking, so that you can tie spaced apart. So that if someone is heading off at the front, and you're not 100% sure that you're safe and you don't know whether how close you are to an edge or if it's even corniced, that there are people behind with a rope that can hold if a person were to slip ahead of them. So ideally you pick a safer line, you don't go near edges, you try and keep track of where you are all the time so that you don't fall off cliffs and edges that way. So when you're taking your bearing, if it's summer, you can do it quite comfortably. In winter, you may choose to kneel down so you can rest it on your knee and have it stable and rest your map onto it and get your compass then on top of it. So, or you can get a group to shelter around you to protect you while you're taking the measurement. And then, like I said earlier, you keep it tied onto you so you don't risk dropping it. It's good to practice taking bearings every time you go out and walk. You're probably not going to use a bearing, but I would suggest you do 1 or 2 just to keep your eye in. Use it to pick out small features, for example. Right, well, if I'm here, I'm going to take a bearing to that tiny little feature over there on the map and see, can I see it with the bearing? And I look out across and see it. It just keeps you practiced. It allows you to look for smaller features as well. And so when you do need it, it's fluent. You've not forgotten how to use it. Just see, are there any questions coming in? Yes, if you do put your phone on airplane mode, the battery will last longer. Yeah. I will make a note of that question. I wrote an article on magnetic and grid north for the Mountain Log probably a year or more ago. I will root out which edition it is, and I could probably include the text in that email as well. So the Mountain Log grid north. It was mainly, and mag north, it was about magnetic variation. That was the question, because a lot of people struggle with the maths of it. It's not difficult if you understand the concept of it, but trying to get a grasp of the concept can be a bit troublesome sometimes. Yeah, so Paul asked the question, if you're on your own in a whiteout and don't have someone to leapfrog for bearings, how do you navigate? Okay, and that can happen, obviously, if you go walking on your own, you can get caught out that way. So if you're in snow, you may have footprints behind you, so that can be a useful thing to retrace, literally retrace your steps. If you're walking on a bearing, you turn around, and where we had been, with the red end of the needle into the bearing, when you turn backwards, the white end of the needle will give you a back bearing, a reverse. So you can follow your steps back to where you knew, if the steps are still visible, if they've not been blown over. That's one thing that you can do. You could check a device to see exactly where you are, tell yourself to calm down, and make a plan, take a bearing, measure a distance, and pace and time it out to safer ground. Like it's quite unnerving when you can't see, and until you've been in a whiteout, it can be quite difficult to comprehend just how difficult this notion of not knowing, when you put your foot out, am I going to hit into the slope, or am I going to drop down the slope? Because you can't, there's no reference at all. It's a complete blank. So I remember coming off the top of a climb. It'd been horrendous. The weather had been very challenging, and the climb was quite challenging as well. And we got off to the top, and they said, "So do you two want to navigate off?" It was like, no, absolutely not. We were very new to it. But the prospect of walking into this cloud of nothingness and risking falling off a cliff was just too much at that time for us. But it's back down to locating yourself, getting your bearing, and walking only a few paces each time, and then sighting again, because you need to stay on that line. It's just very slow. But that's really what you have to do if you're on your own, and you just have to kind of keep at it until you get down to lower, less difficult terrain. Okay, I think we are a bit of chat going on here. I'm not sure, Doreen, what you're saying in that. Maybe if you could clarify. I'm not sure what you're driving at with there at all. My apologies. If you maybe want to clear that a bit and let me know what you're meaning. So the other thing I would definitely suggest when you're taking bearings in any time is to do a guesstimate. So have an idea what to expect. So straight up the map is north, and it's the circle, the degrees of a circle. So straight down is 180 degrees. And obviously, straight out to the east is 90, and straight out to the west is 270 degrees, just the degrees of the circle. So if you're traveling from something up north and you're going across to the east, then that you know what direction you're traveling, you know roughly what number of degrees that's going to be. So when you do take your bearing, you know to expect roughly that answer. And if you get something that's way off, that you've either measured it backwards, you've gone the wrong direction, or you've used the wrong grid line, maybe use the one's going across from west to east rather than the north-south grid line to line up, so you get a 90-degree error. So always with any maths, have a rough idea what to expect for your answer before you start, and that then it should marry up roughly with what you think. So if I'm planning to head see what you can see on the screen here. If I'm planning to head, my apologies, it's quite tricky to get the large scale map visible from that peak there. Backwards for me, so I can't read it. Out to the road junction, I'm heading pretty much east. So if I took a bearing from that top out to that road junction, I'd expect to be getting about 90 degrees. So when I go and measure it on the map, that's what I'm going to expect. And if it comes out at 270, I've probably measured from the road junction back to the mountain rather than the other way around. So a guesstimate bearing is really useful. The other thing you can do when you're planning as well, if you know what route you want to do, you can do a route card the night before and start measuring all those distances and the bearing and the route that you're going to take, the features that you're going to cross, and make notes. You can use a pencil on the back or a pen on the back of it to make the notes of your leg, or carry a route card with you. I wouldn't solely rely on the route card. I would still take my bearing on the hill, so that you can double check it, because when you're not faced with the walk in front of you, sometimes when you're sitting at the house taking a bearing along something, the fact that you've done it backwards doesn't ring any alarm bells because you're not actually on the ground looking at it. So it is useful to do it again and check, but it can be, if you're on your own as well, that you've got a second opinion. Even though there's no one else there, it can be a bit more reassuring if it's matching what you expected. And if it doesn't, it will get you to question it, and it will make you clue in a bit more and concentrate when you need to. The other useful thing with the route card is that you've put in there escape routes. So you've made plans if something goes pear-shaped, if you're tired, if it's getting late, if you're moving slower than you thought, and you need to cut short, that at each step you've said, if I need to go all the way up to here, I just go back the way I came. All the way past there, I keep going because that's the quickest way off. And in the middle ground, that you might choose to drop left off the ridge, or or take this footpath down here and cut the journey shorter. But you've thought about it. So you're not just going to make a snap decision on the hill. The other side of that is that, if I said this the other night, if you're checking a weather forecast and there's avalanche risk on certain aspects where snow has been scraped off one side and dumped onto the other side, it's loaded, you may choose to mark your map and say, right, well, it's all loaded on the southeasterly side, so I'm going to steer clear of those facing slopes, and just mark it on your map and put some lines on it. No go, don't go in this area, because when you're deciding about avalanche, you'll remember it, but when you're deciding about trying to get off the hill quickly, you might forget about the avalanche risk and think that's a nice easy slope, I'm going down there, and suddenly find yourself on a slope that's prone, and realizing fairly quickly, either because you've been avalanched or because you can see the wind, the slab build up on the slope, and it's not a safe slope to be on. So those kind of things can be very useful. It's 8:20. I'm not sure whether I set these for an hour or an hour and a half, but I will definitely finish at 8:30, just to let you know. And I think we're getting through pretty much most things. So coming back to some of the tips for winter, that preparation and planning the night before gets you to think about what you're going to take on the following day. It jogs your memory about what equipment you should have in the bag. It gets you to think about what happens if something goes wrong. Have I got a group shelter? Am I carrying an extra jacket? Have I got enough hot drink, food, to survive a little bit longer if I was a bit slower? Those kinds of things. Have I checked the forecast? And have I taken that into consideration when I've made my plan? I'm not just going to climb Ben Nevis no matter what, but is it appropriate to climb Ben Nevis, or which is the best route to take today because of these conditions? And again, check it in the morning. The forecast may have changed overnight, and no longer is the route a suitable route to take. So you do need to review in the morning, but do your prep the night before. Have a good look at all the information to hand. Make sure you've got the equipment, everything fits, your bag is packed, so that in the morning when you make your early start, which it should be in winter, that you just need to get dressed and get your pack and food and head off, so you're not going to start late. Couple of tips I found very useful going through winter navigation over the years. If you're kind of walking in and you're going to finish on a peak, and you're walking up onto a ridge before you get the summit ridge, and you're sheltered in that approach to the ridge, but once you get onto the ridge, you're exposed. So I found it very useful to take my bearing for that ridge below the ridge line. So when I'm still in shelter, so that when I get onto the ridge, it's like hitting your T-junction, to turn right or left, but you've already got your bearing to the top set. You don't have to stand. And often you'd see candidates just stop on the top of the ridge in the worst of conditions and start taking their bearing because they feel they have to reach that point before they can navigate the next leg. So there's nothing to stop you just being back from that and taking that bearing ahead of it, so it's ready once you hit the ridge to turn and keep going to the summit. In the same way that you can take your bearing from the summit before you get to the summit. If it's a good clear day but just really windy and exposed on the summit, you may choose to take a bearing in preparation of a section and measure your distance where you're sheltered. Take your time doing that. You choose bigger features in winter, things you can't miss, like walking up onto a ridge. You hit the ridge and then you turn right, rather than tiny little features that are going to be concealed. Streams can be concealed and not visible anymore, are not even apparent. So pick and think about what's snow going to do to that feature. How is it going to change the look of it? And what feature wouldn't be so badly impacted that I can't see it anymore. So you may choose to pick on ridges or really obvious features that way. Create a checklist. So if you're trying to get from the valley up the back wall onto the ridge, turn right onto the summit, and then down, have that tick list in your head of maybe 2 or 3 steps on from you all the time, so that you can tick them off and keep going. You don't have to stop every time you reach a feature, and that will keep you moving quicker and staying warmer. And big landmarks help with that. So by the time I get to that ridge line, I'm going to stop for lunch just before I go onto that ridge line. So it'll give you a bit of an alarm bell to eat before you summit, rather than a tendency to stop on the summit, enjoy the view, get cold, have the weather drop down on you, and suddenly you can't see which way to go down. So yeah, to do those kind of things. And I did touch on it a little bit about roping up. Sometimes we carry a walking rope in summer. Sometimes you carry one in winter for a variety of reasons, not because you're climbing, but just because you maybe want a bit of extra protection on an exposed bit of ridge or an exposed bit of slope, or you need someone, on a rope, so that if they're near an edge, or you're not sure if you're near an edge, that the rest of the group can be ballast to make sure that there's no incidents off the edge that way. Okay, I think I have gone through all of the various topics that I had hoped to get through. I'm conscious it's very much of an overview, and there are lots of more specific videos, but it's not really the forum, I suppose, in a webinar to be able to teach and kind of drill things in that way. But so let's see, there's a question here from John. So if you're working on magnetic variation, if you're taking it from grid, this is a memory aid. If you're taking from grid to land, so if you're taking a bearing off the map, the grid, and you want to translate that into a magnetic bearing, then you that variation, so you add it. If you can take a bearing, so say you get a break in the cloud and you can see the top of whatever it is you're trying to get to, or the car park that you're trying to get down to, or the next leg of your journey, you can quickly point your compass at it, turn the dial around to line up with that magnetic needle, and then you can use that then to walk on. So you don't need to do any variation then, because you're taking a magnetic bearing. If you wanted to do that to check what way that ridge line is going, because you're not sure where you are and you want to check what way it's pointing, you can point your compass down the ridge line, move your dial to line up with the magnetic needle, and then put it back onto your map to see which aspect of slope it's pointing you in. And to do that, you'd need to take it off. So from land to grid, you'd get rid. So from the map to the land is the main one you need to remember. The other's opposite. So, okay. Sorry, you're going to have to tell me what EPIRB stands for. Rachie. Just see, there was something there now. YMCA your map to compass, and it sounds like another mnemonic, but I'm not quite sure what way it works. Doreen, you're very welcome. YMCA. I'm not sure what YMCA is standing for. So I'll give you a second, Rachie, and more Doreen. Sorry, if you want to. Okay, so this is like a location device. So your phone is a location device as well. You can set it up so you can be found. That would be one thing. There is talk about carrying shovel probe transceiver when you're out in winter conditions. You can do. It's extra kit to carry. So if you're avalanched, you have in your group, you have a transceiver so you can be found if you're buried. You need to know how to use them, and you can do. They're not. It's not necessarily that you're going to carry them all the time. A lot of skiers carry them, because often they're on terrain. If they're off piste, they're often on terrain that there's they're more likely to come across avalanche terrain. But obviously ski areas avalanche as well. So yes, you could do if you wished, but it's not. It depends, I suppose. If you have one and you're happy to carry it, by all means. But everyone in the group's going to need to carry them to find you, and to be in the same position as you to use them and know how to use them. You're welcome, Noreen. Um, so the grid to land is the northern hemisphere, if that's answering your question. At the moment it is, but if at the moment, if it's 4 degrees, for example, if it's 4 degrees in Wicklow this year, in 6 years' time, it's losing 10 minutes a year. It'll be 3. So in 24 years' time, it will be 0 in theory, if the correction is still the same. And in 28 years' time, it should be minus. So it'll take a while, but if it all keeps going in the same direction, then eventually, and that's why I said it's useful now, but it may not stay that way forever. So I hope that answers your question, Paul. Just see. Yes, and just in terms of avalanche, a lot of folk don't feel that we have avalanches in Ireland, or it's just really the Alps and Scotland, the Himalaya, the big ranges, or the place where they get lots and lots of snow. But we have had avalanches in Ireland, and Kevin Smith's saying full depth avalanche in the Pentlands today. So it's not just the kind of the big mountain areas that we're familiar with getting lots of snow, and there are different types of avalanche as well. So in the Alps you might get one type of avalanche or a few types of avalanches, but in Scotland you get quite different types, wet, heavy, so it is a bit of it does take a lot of experience to work out how to interpret and read, and that's where the avalanche forecast that they provide in Scotland is very useful. It helps you to kind of decipher what is a science, and takes a lot of skill. So how do you think winter skills in Ireland compared to high level walking in the Alps? Yeah, that's a really good question. I'm on Monday, I'm giving a talk actually on, we run an alpine meet every year. We run a winter meet every year. Not going to run this year, unfortunately. This the winter meet, and the alpine meet is, see how we were able to travel. But yeah, it is. It's quite different. Let me just see. So a lot of the same skills are used in the Alps that you would use in Scotland. I do think getting a Scottish training first is a really good grounding for the Alps. Certainly learning how to snowhole saved me in the Alps. We got caught out in a very bad storm. So having those skills to know how to survive in really poor conditions, wet, slabby, wet snow that you get a lot of in Scotland, and lots of bad weather and cold, damp, wet, and really helped, in the alpine conditions, when often you're climbing in the Alps and it's in good weather and it's sunshine and the snow is quite dry and the conditions are quite dry. So it can be quite different, but a lot of the same movement skills, kit, all of those things, they cross over, and a lot of the same things that you're going to need, the skills, are useful in both places, but there's a lot of differences as well. So yeah, like the Alps are far more pleasant in general, I have to say, warmer and sunnier, crisper and cleaner, and all of that kind of snow that you get with that, where in Scotland it's a lot damper and wetter, but it is unique, it's fantastic. So yeah. Okay guys, we are just hitting past. I'm just going to get the last. Yeah, someone's put the Scottish Avalanche Information Service link up there. That's already there in the follow-up email I'll put together. But Yeah, someone just mentioned another version of EPIRB, mainly used for marine situations, they're saying, and Spot is available, another type. Okay, I think I see lots of people heading out the door. Thank you so much for your time. The video will be up on the website in the next day or two. A few more questions still coming in. Um, yeah, I'm not gonna. Yes, if you get your bearing wrong, you will end up in the wrong place at the end. If you wander off it slightly, you'll end up in the off by an amount. If you're walking on a very long bearing, you'll end up being off by more than if you do a shorter leg. But I'm not going to go into the math of it just because the questions are disappearing off so fast. You're very welcome, everybody. I hope you enjoyed it. There's plenty of videos on the website for some of those subjects that I glanced over that would be better seen, and equally lots of outdoor sessions. Okay, so you're very welcome. Oh my goodness me, from Albers Massif in France, Tom. You're lucky to be somewhere nice, I think. But my Ireland is beautiful here at the moment. Yeah, you can turn back if you don't feel safe to go ahead. Yeah, very sensible. The mounting is not going anywhere. It'll be there another day. Um, thank you very much, everyone. You're very welcome. And if you do want to come on Sunday, please book just so that I know how many to expect. Um, you're all welcome. Okay, so thank you very much, everybody. I'm going to stop the recording now, and thanks and good night.